Okay, so first part, I've got to find the exact value of this. So the integral between 1 and 9 of 7x plus 1 to the third dx, it equals, in square brackets, so I'm going to integrate this, so I'm going to have 7x plus 1, I'm integrating it, so that means the power has to increase, so it's going to be 1 more than that, so 1 on the third or 4 thirds. But if I were to differentiate that, I'd get 4 thirds coming down to the front. I don't want that, so it's going to have a 3/4. Times by this bit to the power of a third, but then I also have to differentiate the bracket, which gives me a times 7. Don't want that, so I'm going to have to times that by 1/7. And that's how my mind works with it. And that's between 1 and 9. And so that equals 3/28 of, put in 9, 7 on 63, that's 64, that's nice, it's a cube number, to power 4 over 3, minus 3/28 of putting 1, 7, 8 to the power 4 thirds. That's also quite nice. So that's 3/28 times by cube root of 64 is 4, 4 cubed is 256, minus 3/28 times by cube root of 8 is 2, 2 to the power 4 is 16, and actually doing that on a calculator, mine gives me 180/7, and that is the exact value. Part 2, I've got to use Simpson's rule to get an approximation for this, okay? And it's going to come to just 2 strips. That's quite nice. It's not going to take long to do. So I don't know what the curve looks like, but suppose it were to look something like this. 2 strips means I've got to go like so. So I need a value for x0, I need a value for x1, and I need a value for x2. So that gives me y0, y1, and y2. So now I can work out what I got. And x0, this is going from 1 to 9, so that's going to be 1, and that's going to be 9, and so the middle bit will obviously be 5. So that's what I've got. So I've got my x0 value is 1, my x1 value is 5, my x2 value is 9. And I need to know what my y value is, and y equals 7x plus 1, the cube root of that. So when x is 1, the y value is, that's 8, the cube root of 8 is 2, x is 5, that's 35, 36, that's the cube root of 36. Well, that's good, because I've got a cube root of 36 there. X is 9, 6, 7, 9, 63, plus 1, 64, and that would be 4. And now I can work it out, because I know that the area, the integral of y dx between a and b approximately equals a third of h times by, and it's in the formula sheet, I have the first one and the last one, and I've got 4 lots of all the odd ones and then 2 lots of all the even ones, but I haven't got any even ones, so I've got to have 4 lots of y1. That's the one, clear that up, let's make it clearer. 4 lots of y1. And it goes on, but that's all I need in this particular instance. So the area approximately equals 1/3 times by the height, or the gap between them, which is 4, times by the first and the last, so 2 plus 4, plus 4 lots of the cube root of 36. And that equals 4/3 of 6, which would be 8, plus 4/3 of 4, so that'll be 16/3 of the cube root of 36. So I have expressed it like they wanted, so just make it clear, m equals 8 and n equals 16/3. And then the final bit, work out the approximate value of this. Well, we know, I'll do it in red, so part 3, we know that the approximate value of the thing, so 8 plus 16/3 times the cube root of 36. That's the approximate value. We actually know what the real value is. The real value is 180 over 7. So all I have to do is just rearrange this so I get the cube root of 36. So if I take away 8 from both sides, I get 16/3 of the cube root of 36 equals 180 over 7, take away 8. And then I'm going to get the cube root of 36 equals times by 3 and divide by 16, so 3/16 of that. And that's equals 3/16 of 180 over 7 is 135 over 28. Minus 3/16 of 8 is minus 3 over 2. And that equals, on my calculator, 93 over 28. And that is given in form P over Q. And that is P over Q and as a fraction. And that's 7 done.